Now that we know about using predefined objects in Java, let's create a program for Pay Best Shoes, their BOGOF sale. Here's the problem statement. Pay Best Shoes is having a buy one, get one free sale. The free item has to be equal or lesser value than the purchased item. So we need to write a program that allows a user to enter their purchases and calculate how much they'll pay. So the first thing we need to do is to create some test data. Suppose our items cost $3, $7, $9, $5, and $1. Well, you've got to think this through carefully because when you pay for the $9 item, you're going to get the $7 item for free. When you pay for the $5 item, you're going to get the $3 item for free, and then you're going to have to pay for the $1 item separately. So that means that you're going to pay for the $9, the $5, and the $1 item, $15. Suppose our items cost $12, $8, $4, $10, $6, and $2. Well, we're going to pay for the $12 item, get the $10 item free, pay for the $8 item, get the $6 item free, and pay for the $4 item. So that should be $24. Boundary cases we might want to consider. Well, certainly if we buy 0 items, we want to pay $0. If we buy only one item, maybe a $10 item, we want to pay $10. And if we have a $10 and $8 item, we're going to pay $10. One thing you may have noticed when I was talking through that creating the test data is it's actually giving us some ideas about how we might want to write the program. So what I was doing was sort of sorting the data and thinking about I'd pay for the first one and then not for the next most expensive one. So that strategy is the strategy we're going to use in the program. This is why it's so important to work through test data first, because it can actually help you figure out how to write the program better. Let's choose our data types. We're going to need to store and manipulate the price of many items. We really have only one possible data type that could work for that. It would be an array list of doubles. So let's go create our program and get our array list of doubles in place. So we're starting Eclipse. I'll create a new project. Notice that I always get rid of the code from the old project before I create a new one. That's very important because particularly if your projects have the same names, you can get confused and be entering the wrong project's code. That's a really serious problem. So here's our project. There's our source file. Here's our class. Which we will, of course, beautify as we always do. We know we're going to need an array list of double in our code, and I'll call it sales. Eclipse is complaining because, of course, I have not imported the file for ArrayList yet. So we're going to import java.util.ArrayList. That way, Eclipse can find the ArrayList instructions and is able to create the ArrayList object. Let's think about designing our methods first. This is different than what we did in the last chapter because this time we actually can store our data. So our input and calculations don't have to be done together. They can be done separately, which is actually a nice way to do it. So if we're going to get the user purchases, the input is probably going to be a scanner, although we may want to think about that a little bit. The output, the return type, will be an array list of doubles. This means that our array list of double will be created inside getUserPreferences and then returned to the main program. This will be a static method, as all of our methods have been so far. We also can create a findSalePrice method. So this can be separate now because we have the array list to store our data. The input will be our array list, and the output will be double. That will be the sale price that's getting passed back. This is also a static method. So let's go and write those methods. I'll put in stubs first. Now we're going to have to think about whether we want a scanner here or not. So we'll deal with that problem in a minute. Okay, so let's think about the scanner issue. Is all of our interaction with the user going to occur in this one method? If so, the scanner can be a local variable in that method instead of being a parameter to it. Or you can always put your scanner in the main program. It really doesn't matter which way you do it. Both ways work well. Because people get a little crazy about parameter passing, I'm going to put the scanner in the main program and then pass it in as a parameter, just to get a little more practice. But either way would work just fine. Of course, Eclipse is complaining about our scanner once again because we haven't done our import statement. So since we created it in the main program, we want to pass it in now to get user data. Now, Eclipse is putting a lot of little red X's around, and the reason it's doing that is because we haven't returned the types that we expect. So if you look at these little red X's, what they say, this method must return a result of type array list of double. So one way to keep Eclipse quiet is to create that array list and return a fake one for a while. That will keep Eclipse off our backs, so I like to do that. I'm constructing it with a constructor, and then returning it. And now Eclipse is happy once again. Now in this method, we're just returning a double. Since double is a primitive data type instead of an object, we can just return 0.0 for now. So that will keep Eclipse happy. The next thing we need to do is define the sale price. Now this one is a little bit tricky. First we need to sort the data from the smallest to the largest. Now you might say, wait a minute, when you were going through the data you looked from the largest to the smallest. And that's true, that would be a really nice order to have. Unfortunately though, the methods that we have to do sorting are always going to sort in ascending order, that is from the smallest to the largest. So we're kind of stuck having to deal with the decisions that are made in Java. We're going to have to buy the most expensive item, so that one's going to be at the end of the list. The second one will be free, so that's one position in, and then we'll do every other item. So if you think about it, we're starting at the end and skipping alternate items. So that's a nice little while loop we're going to have. As far as our implementation choices, well, sorting is always in ascending order. There is a method in the collections class that reverses data, and we could use that. But there's really no reason to use that when we can just start at the far end of the array instead of the near end. This is a possibility people sometimes forget to do when they're writing code. So let's go and write the find sale price method. So we take our array list and we sort it. So that's collections dot sort purchases. Now we want a loop, so we're going to start at the far end. So let's call an index, and that's going to be purchases dot size minus 1. Now that minus 1 is easy to forget. Remember that size is unit indexed. That is that it counts the number of elements that are in the array list. But unfortunately, the elements themselves are 0 indexed. And so we always have to subtract 1 in order to get it started in the right direction. So while index is greater than or equal to 0, Well, we need to keep track of how much our cost is going to be. We'll start it at 0, of course. While it's greater than or equal to 0, we will add in the cost at that index. So cost equals cost plus purchases.get of index. And the next thing we need to do is to change the index. You may be tempted to subtract 1 from index because we've written so many loops where that's the correct answer. But in this case, you need to skip items. So you need to subtract 2, not 1. Now instead of returning 0, we'll return cost. Now we could run the program at this point, but it's not going to be very interesting because we haven't written our input method yet. So probably that's the one we should do next before we try to run. So here's our getUserData method. We might want to think about how we're going to have the user enter data. This can't be a counter-controlled loop because we don't know how many purchases the user is going to make. It's really not nice to ask users for things like how many purchases are you going to make before you start. And so instead it's better to use a sentinel. That is to have them enter some illegal value at the end so you know that they're through. In this case, because they're entering the cost of items, -1 makes a good sentinel. Because it's a sentinel controlled loop, we're going to have to prime the reads. So here we go. System out print line. Enter the cost of your next purchase, or -1 to stop. Then we'll have a double called cost, and that will be keyboard dot next double. Because this is a priming read, we want to include a comment. So we'll have while cost is greater than 0. Now this is an important point. You may have been tempted to write while cost is not equal to -1. But the problem is that cost is a double value, and we do not use equality comparisons with double values. Because doubles are not stored exactly in the computer, using equality comparisons with doubles will sometimes work and sometimes not. We don't want to take risks like that with our program. So instead, we'll just look to see if the value is less than 0. By using less than, we get around that problem. So now we're going to add the element to the array. And we're going to get our next input. Now we've already written our priming read input. So let's copy and paste that into the loop. Of course, we have to remove the second declaration because we're only allowed to declare cost once. And let's check what we have at the end of the loop. We're returning the result, and so that's correct. So notice this was kind of a lean, mean loop, not a very long one. Let's go to our main program and make sure we have the pieces together correctly. Well, we really don't have our pieces together correctly because we haven't called any of our methods. So we'll say sales equals getUserData of input. So that method is returning our array list. Now we're ready to find the cost. So we'll have double cost equals, let's go and look for what the name of the method was. Find cost. Clever name. So we're going to find cost of sales and system out print line the cost of your purchases is plus cost. Well, Eclipse is happy, so let's see if our program is running. So let's start with some easy data. Let's just make one purchase of 10 bucks. Ooh, that worked. That's good. Now let's make two purchases of $10. This should be 10 bucks, right? And that worked too. How about $10 and $8? Purchase is $10. Remember the $8 item being free. Now, $12, $10, $8, $6, $4, $2. So it'll be 12 plus 8, which is 20, plus 4, so our answer here should be 24. And it is. Things are looking good. One thing I will say about our testing strategy so far, because I've had all the data in order, we're really not testing whether the sorting is working correctly or not. So let's try the data in the opposite order to make sure that our sorting algorithm is doing what it should. So $2, $4, $6, $8, $10, $12. And it's the same $24 cost. So this time we didn't make any mistakes while we were creating our program, more or less. One of the reasons we didn't is we had a good strategy to start with. And that strategy came from doing the test development first. So that's an idea you definitely want to consider when you're writing programs on your own. So we've checked our test data, and our program is finished.